Okay, so this is just a quick video to help you guys understand what is going on with the half of it lab. So this is a lab about radioactive decay. We've already talked about types of radioactive decay, so you guys know that there's alpha decay and beta decay, positron emission. But in this lab, we're going to be talking about how long that decay takes. And it has to do with something called half-life, which you've heard of, but we haven't talked a lot about yet. So basically, when a group of atoms that is radioactive decays, we divide the time that they are decaying into these intervals called half-lives. And we're going to go to the data table, so you have this on your Google Doc. We're going to simulate this with dice. So I've got 100 red dice here, and we're going to say that they are all radioactive right now. So at period of decay 0, so this is like at the beginning before anything has decayed, we're saying all 100 of my atoms are radioactive. And I've got an actual and a theoretical column. I'll talk about the difference between those in just a second. This column, we are counting the total number of atoms, so those that have decayed or turned into a different element, and those that are still radioactive. And you'll notice I filled this out for you because the whole time you're going to have 100 atoms. Down here, all of them are going to have decayed into a new element, but you still have 100 atoms. The atoms don't just disappear. So that's what this column is trying to help you understand. The atoms don't disappear. Okay, so what we're going to do is I'm going to pour out all the dice, and we're going to say all of the dice that have a 1 or a 2 or a 3 have decayed into a new element. Okay, so if I look at these and count all of the ones that have a 1 or a 2 or a 3, so I divide them up into sections and count them, about half of them are going to have decayed. Okay, so for the sake of time, I'm not actually going to count all those, but generally in class, people will get numbers pretty close to 50, but not exactly. So let's say maybe we've got 53 that are, I guess 53 are decayed, and then that would mean that I would have 47 left that are still radioactive. So all the dice that have a 4 through 6 on them are still radioactive. And that's just following the instructions right here. So everything that has a 4 through 6 is still radioactive. So just pretend I counted those, and I got 47 dice with a 4 through 6. So those ones are still radioactive. They're still that same element. The other 53 have decayed. Now let's look at this theoretical column. So the theoretical column is what would happen if exactly 1/2 of my atoms decayed every single half-life or period of decay. So exactly half of 100 is 50. And then exactly half of 50 is 25. Now half of 25 is 12.5, but I can't have half of an atom, so I'm going to round up to 13. And then half of 13 is 6.5, so I'll round that up to 7. And then 3.5 I'll round up to 4. And then 2. And then 1. And then we'll maybe round up to 1 for a while. And then finally that last atom is going to decay. So it would be all 0 all the way down. Now, what I would normally do is I would take those 47 dice that are still radioactive, that had the 5, 4, 6, and I would put them back in here, and I would shake the jar again and roll them all out. Okay, so pretend I counted 47. I don't know if that's actually 47. Okay, and I would count the ones that have 4, 5, or 6 are still radioactive. The ones 2s and 3s are not radioactive anymore, so I separate those into 2 different piles. All right, and let's say I counted them, and let's say I got this time 26. Okay, and so what I'm going to do is I'm going to just kind of give you some data here that you can put into your Google Doc, and then you can use that data to make a graph and answer all the questions. So we'll go 15, 7, 3, 1, 1, 1, 0. All right, so this is your data. Go ahead and use that to make your data table and answer the questions.